how to calculate the root mean square, the average speed, which is the VA, and the VP. From the question above, we see calculate the molecular speed of nitrogen gas at 300 K. For you to calculate the VRMS, it's either you are using this 3KT all over M or 3RT all over M. I'm going to explain it immediately. And then you don't need to suffer yourself. All you need to do if they ask you to calculate the average speed or the probable speed is for you to use this formula. I've already written it down there. Now, let me go proper and start calculating. Now, we have the VRMS. So it is equals to 3KT all over capital M. Please, the T in this formula is the temperature in Kelvin. Please note it very well. This is the main thing what we are doing here now. The T is the temperature in Kelvin. The K is called the Boltzmann constant. The Boltzmann constant. And the Boltzmann constant has a value of 1.38 times 10 raised to the power minus 23. 1.38. This is a constant and it's called the Boltzmann constant. Now, the mass, this mass must be in kg, not in grams. So note that also very well. Now, you already know that, so if you want to use this formula, you should know this. Right now, so from the formula, from the equation, we know that we already have our T to be in 300 Kelvin, right? And then K is a Boltzmann constant, so this is for me to get my mass. But you already know that the atomic mass unit of nitrogen is 28.01. The 28.01 atomic mass unit. Now, but the mass must be in kilogram, not in atomic mass unit. It must be in kilogram. So right now we have to convert from the atomic mass unit to kilogram, and there is a conversion factor about this. 1 atomic mass unit will give you 1.66 times 10 raised to the power of minus 27 kilogram. So the conversion factor is this. Please, I have a video on conversion factor. If I'm talking about conversion factor and you're having a problem, please check the channel immediately. So this is the conversion factor that 1 atomic mass unit is equivalent to 1.66 times 10 raised to the power of minus 27 kilogram. Now, remember this is under atomic mass unit. So look at it. You will start with the one given, 28.01 atomic mass unit all over 1 times. Now this is the conversion factor. You want to move from here to here. So all you need to do is you have to place this one at the bottom. So here is 1 atomic mass unit, and this is the conversion 1.66 times 10 raised to the power minus 27. Now, why am I placing this at the bottom? I want to cancel because this atomic mass unit will cancel atomic mass unit. I want to move from an atomic mass unit to kilogram. That's why I put it at the bottom. If I put it at the top, it cannot cancel. So that's why I put it at the bottom. So you can see that this atomic mass unit cancel this atomic mass unit. Now, if you punch this on your calculator, what you will get is 4.651 times 10 raised to the power of minus 26 kg. Now your mass is already in kg. All we need to do is put it into this formula and the answer will flow naturally. So this is 3 times your K, the Boltzmann constant, 1.38 times 10 raised to the power of minus 23 times your temperature, which is already in 300 degree Kelvin. So you divide everything by 4.651 times 10 raised to the power of minus 26. Now punching this into your calculator will give you an answer of 517 meter per second. Remember the velocity is always in meter per second. Now So you get your 517. Now the next thing is, how can you use this formula? This one, VRMS is equals to 3RT all over M. Now here, of course, that R is a universal gas constant. The T is the temperature in Kelvin. Now the mass is in kg per mole. It's in kilograms per mole, not in kg. It's in kilograms per mole. So whenever you're using this formula, know that your mass here is in kg, but here is in kilogram per mole. So remember, we're going to have to do a simple conversion too. And the conversion is, remember, the atomic mass unit of nitrogen is 28.01, right? And please know that atomic mass unit is the same thing as relative atomic mass, and the SI unit is gram per mole. Is it not? Yes, gram per mole. So this is in gram per mole already, but we want to convert it to kilogram per mole. And you already know that 1 kg is equivalent to 1000 grams. That's the conversion factor. That is the conversion factor. Now, please, can you pause the video and immediately try to solve this on yourself? Can you pause the video? Now, if this is in gram per mole, this is 28.0 gram per. In physics or in chemical, with physics, whenever we say per, it means all over. So all over, look at your mole here, right? The conversion factor right now, I want to cancel gram. So that means the gram have to be at the bottom. So this is 1000 gram. And I want to move to kilograms. So this is 1 kg. This will cancel this. Is it not? So you are left with 1 kg and this is mole. And that is what I want. We want our kg to be at the top while the mole is at the bottom. That is what? Because I told you that the mass must be in kg per mole. So dividing this, what you will get is 28.01. If you divide it by 1000, what you get is 0.02802 kilogram per mole. Now that is it. So all you need to do is now insert it, you still get the same answer. So VRMS is equals to root of 3 times 8.314 times 300 divided by 0.02802. You will still get the same answer of 517 meters per second. So please know which of the formula that you want to use. Now remember, we have to also calculate the probable speed, which is the VP, and your average speed, which is the VA. So, and that's the formula. So if you want to calculate your VP right now, all you need to do is your VP is 0.816 times your VRMS, which you have already calculated to be 517. So if you punch it in your calculator, your VP is 421.872, and your VA, look at the formula there, 0.921 VRMS. So this is 0.921 times 517. That should give you an answer of 476.157. So please know the two ways for you to get that VRMS. You can just get your root mean square velocity. To get VA or VP is a child's play, as you can see at the board. That should be all for this video. Thank you very much.